Let's look at some trig function integrals. So here we have the integral of sine 5 of x dx. And the first thing you might think of when solving this is doing some sort of u substitution. But when we try to do u substitution, we won't be able to because we're missing our cosine term. So we have to start thinking of a new method in order to evaluate trig functions that are particularly different or raised to some sort of power or different than just a standard sine of x or a cosine of x. And so when we're looking at these types of functions, we need to start thinking it in terms of trig identities. So here we have a list of different trig identities, and there's more than just this, but these are the most common that you'll use in order to simplify integrals. So here we have the one that we'll be using for our example problem, but some other common ones are the half angle identities, as well as the double angle identities. You'll see this throughout different example problems that you might come across. So here, let's go back to our original example problem, sine 5 of x dx. We can go ahead and simplify this to read sine squared of x squared multiplied by sine of x. So this is just sine 5 of x that's been expanded. And so now we can leverage this trig identity in order to replace the sine squared of x with a 1 minus cosine squared of x. And so we'll have the following expression, which we can now use u substitution. So we'll set cosine of x equal to u. So we'll do that here. And then we can go ahead and take the derivative to get negative sine of x dx. We can move this negative symbol over to the du side. And now we can go ahead and plug in our u into our integral, expand this middle term, or this 1 minus u squared term. And so we'll get the following expression, and that's easily integrable. And so we'll have our solution, and then we can go ahead and back substitute cosine of x for u and get our solution.